this is the Excel solver scenario. If your computer does not have solver on it, you first of all have to install it. So to install it, you go to File, Options, Add-ins, Excel add-ins, Go, and if you notice, Analysis Tool Pack is one of the, or I'm sorry, Solver is one of the things that we're going to add. So that's how you go about adding the solver function to your computer. All right. First off, put your name in the name box. We're going to solve problems with multiple entries and use the solver function to solve two-equation algebra. Previously, we used Excel formulas when we knew all the values except one, and we used GoalSeek to solve those applications. In this lesson, we're going to use another Excel function, solver, to solve systems of equations where we have two variables. Let's look at this first one using Excel Solver. So you know you have Excel Solver installed if you click on let's see, data, and you see it over here on the left-hand side. It says, or right-hand side, it says solver is one of the choices. And then it tells you how to add it if you don't have it. Okay, we are going to solve this first one right here. I'm going to make it smaller so that you can see everything that happens at the same time. Enter the x and y coefficients. I'm on step 1, and the constant values into the matrix. So 7, 8, negative 34. In the second row, it's negative 4, 1, and 25. For this cell reference, this is where it gets just a little bit tricky, because what you need to do is to take the x, I show you how to do it up here in this section, but you type equals the x coefficient times the x variable plus the y coefficient times the y variable. And you do the same thing in the second row, equals the second row's x coefficient times the x variable plus the y coefficient times, y coefficient, come on, y coefficient times the y variable, which is J55. Okay. If you don't know what you're doing, you can see what you're supposed to type in these two pink boxes. Once you have those filled in, you can click on the variables, because those are the things that are going to be solved. Then when you click Solver, just a second. But then when you click Solver, it tells you how to set it up here. If you notice, we leave this first row blank. We don't need to worry about that second thing, but we're going to change the variables. Here are our variables for this problem. Right, where are they? Right here, our variables are these two cells. And we're going to do it, I'm going to delete these constraints, and I'm going to make our first cell references be the coefficients of our equation, the negative 34 and the 25. And I'm going to have those equal to our cell reference, that are formulas that we have. So I have the first column here, the negative 34 and 25, equal to the cell references, which right now are 0 and 0. And that's because it hasn't figured out what the two variables are. So now when we click OK, it goes through solver and it solved it for us. We just don't know what the solution is. Keep the solver solution. It tells us it's -6 and 1. So we're going to put in -6 and 1 in for x and y. Next one. Same kind of a thing, except for these are scenarios. These are real world problems. Jane has 8 quarters and dimes, which total $1.25. So I have dimes plus quarters is 8. Dimes are worth 10 cents, quarters are worth 25 cents. So 10 cents times the number of dimes plus 25 cents times the number of quarters is $1.25. So I have 1D plus 1Q adds up to 8. I have 0.1D plus 0.25Q adds up to 1.25. Now, since the cell references are the same as before, I'm just going to copy these cell references that we had before, save a little time, and paste them down here. Because what it's going to still do is that same thing. It's going to take the x times the x variable, the y times the y variable for the first equation, and then do the same thing for the second equation. But since we already wrote it once, we don't need to write it twice. Now when we press solver, okay, we're going to change the variables. This time our variables are down here in these two spots, J72 and J73. We're going to change our constraint so that now we're going to add these two constraints are equal to these two cell references. And now when we click solve, it tells us that the number of dimes is 5 and the number of quarters is 3. Same thing over here. How many liters of a 25% solution must be mixed with 12% with a 12% solution to get 13 liters of a 15% solution? So we've got weak and strong add up to 13 liters. The weak is 12%, so that's 12 times W. The strong is 25%, so that's, why did I write 13? That should be 25 times strong. Adds up to 15 times 13, which is 195. So now when I put in my variables, I get 1 weak plus 1 strong adds up to 13 liters. That's my liters equation. And then I've also got a acid or solution equation. And that's where we have 12 weak plus 25 strong adds up to 195. Now I'm going to use the same cell references. That's the beauty of Excel. You can just copy those cell references over because it's going to multiply the 1 times the W variable and so on. Okay? Now when I call up solver, I'm going to change my cell references because I now have to use these two here. And I'm going to change my constraints, delete that one, and add a new one that says these two values here are equal to the cell references here. And now when I press solve, it tells me that I have 10 liters of the weak and 3 liters of the strong. Okay, keeping on going. What happens if we have 3 equations and 3 unknowns? Well, it turns out the same, but solver starts to lose its attractiveness here, and I'll show you why. It says a total of 350 people, so they were adults, 1 adult, 1 times the number of children, 1 times the number of seniors. They added up to 350. Now, since it says there were twice as many adults as children, that's here. twice as many adults as children, so adults is twice children. So if we get the children on the same side as the adults, we have A minus 2 children. We have no seniors, and we're going to end up with 0 because there's nothing left on that side. So our second equation would be 1, negative 2, 0, 0. Our third equation, one also, equation is 4 children. 4 children on the other side, we have 0 adults minus 4 children plus the number of seniors is 0. Put in the variables 0, negative 4, 1. Now our cell references are the place where it gets more complicated to solve. It's the A. I should change these to A equals children equals and seniors equals. There you go. All right. So the cell reference will be equals the number of adults times the adult variable plus the number of children times the children variable plus the number of seniors times the senior variable. Same thing in the second row, equals the number of adults times, the coefficient of adults times the adult variable plus the children times the children variable plus the seniors times the senior variable. Oops. And then finally for the last one, the number of adults, or the coefficient of the adults times the number of adults plus the coefficient of children times the number of children plus the coefficient of seniors times the number of seniors, which is H111. No, it's not H110. Oops, I must have made a mistake there. Let's do this one over again. Equals the adults times the adult variable plus the children's coefficient times the children's variable plus the senior's coefficient times the seniors. Oh, it's J110. I said H, but it should have been J. Okay. So now when we press solver, a couple of things change. First of all, our variables change because now we're going to have these 3 boxes instead of 2 boxes. And the other thing that changes is our constraint changes. We're going to add a constraint where this row equals our cell reference row. All right, now when we, what? Oh, I put in an equal sign there, sorry. Unequal number of cell references in constraints. So let's try it again. Our constraints equals our cell references. All right. Now when we press solve, keep solver solution, it tells us we have 100 adults, 50 children, and 200 seniors. Must have been a old-timer movie or something. Next one. The investor paid, these are an application of money. The investor earned $38.70 interest in 1 year from 2 accounts. The annuity paid 6.3% yearly, and the money market account paid 4.5% yearly. If the total investment was $70,000, how much money was there? You can determine the interest from the formula that says interest is rate times time, or principal times rate times time. So we have principal here, which is the annuity and the money market, add up to $70,000. The interest is the annuity times 0.063. 0.045 times the money market is the amount of interest that comes from that, and those two add up to $38.70. So our principal formula is the annuity amount plus the money market amount is $70,000. The interest one says 0.063, that's the interest rate of the annuity, and 0.045, that's the interest of the money market account, and that adds up to $38.70. Now, for our cell references, I'm going to go back up here and copy our cell references that we used in one of the previous ones, since it's a 2x2 matrix again, and I can fill those in. And now when I press solver, I'm going to change this, my variable, to the two variables that I've got, annuity and money market. And I'm going to change the constraints. I'm going to delete that one and add a new constraint where those two constraints equal our cell reference constraints. And press solve. And it tells us that we have $40,000 in the annuity. And we have $30,000 in the money market account. All right. Let's see what the next one has in store for us. Find the cost per can of chicken noodle soup if 8 cans of chicken noodle soup and 6 cans of beans with bacon cost a total of $16.04, and 3 cans of beans and bacon soup and 10 cans of chicken noodle soup cost a total of $14.92. The difference this time is that the variable is the price rather than the number. So the bean with bacon soups, we have 8, we have 6 and 8 chicken noodles, and they add up to $16.04. The second time we have 3 bean with bacons and 10 chicken noodle soups, and they add up to $14.92. I'm going to copy the cell references so that we don't have to retype them. And then our variables will be our solver amounts. So when we click on solver, here's our 2 variables. And our constraint, we're going to add a constraint that our constant terms equal our cell reference. And when we press solve, we get $1.14 and $1.15. And somehow we didn't get the total number of points. Let's see where we made a mistake. So we should have the total number of points here. Oops, here we go. We missed one right here. 0.25. There we go. That's still not everything. Oops, here's another one, 0.10. There we go. Now I think we've got them all. Okay, so now you've got your 30 points, and that's how you do it.